today we're starting our next unit. We're going to be starting off with parameter changes. So all that really means is changes that you make to a line when you graph it. So just that linear function, y equals mx plus b. We're going to talk about what different numbers in different places do to the line. So first they ask us to recall what the parent function is. Remember, the parent function is our equation with no changes made to it, right? So if our linear equation is y equals mx plus b, then that would mean that our parent function is y equals, the most basic slope we can have is 1, right? So 1x or just x. And if it's had no changes made to it, it hasn't been moved up or down. So if there was a plus b, it would just be 0. Okay. So this is the equation for our parent function. So, like we just said, that would mean that m is 1 and b is 0, which means if I had it on a graph here, it's going to go through the coordinate point 0, 0, right? Because it hasn't been moved up, hasn't been moved down. So it's going to cross the x-axis at 0, 0, and it crosses the y-axis at 0, 0, since it goes through the coordinate. So when we change the parameters, we're really changing either the slope or the y-intercept or both. So this part can change and this part can change. So now we're going to look at what that looks like depending on what part we change. So first it says, what would happen to the graph over here if we made the slope larger? So it gives us the first one, which they already graphed over here. They wrote up there in the corner that this is y1. All right, we're going to graph y2 and see what the difference is. So y2 also doesn't have a plus b, right? So it still starts at 0, 0. But my slope, or my m, is 2, which means I'm going up. Very good. So if I connected those points, this is the line I have now. So this is y2. All right. Then we're going to graph y3. So again, it doesn't have a plus b, starts at 0, 0, but the slope for y3 is 3. That means I'm going to go up. Very good. Okay, so here's y3. And then we're going to graph that very last one, y4. Again, no plus b, but my slope is 6. So that means for every point, I'm going to be going up 6 over 1. Okay, so it wants us to draw a conclusion based on these new lines be true. So we started off with y1 here, and then when I graphed y2, we were here, and then y3, and then y4. So what was happening each time? Right, it's getting steeper. That's exactly right. So that must mean that the bigger my slope gets, the steeper the line gets, right? Okay, so that's what we're going to write. As the slope increases, the line gets steeper. what's going to happen if our slope's getting smaller, we probably have a decent idea, because it's probably going to be the opposite, right? But we're going to go ahead and graph these so that we have a proof for it. They already graphed y1, so we're going to start by graphing y2. Again, there's no plus b, but my slope is 1/2, so that means I'm going up and over how much? Very good. Okay, there's our y2. All right, y3 has a slope of 1/3. So when I graph y3, I'm going up 1 and over 3. All right, and then the last one we have to graph is y4. Has a slope of 1/6. So I'll just go up 1 and over 6. Okay, so again, they're asking us to draw some conclusion after graphing these 3 lines. So I started out with y1 here, and then I graphed y2, and it was here. Then I graphed y3, and it was here, and then y4, a little below that. So what happened to my line this time? It became less steep, right? Narrow would mean a little bit closer together, which it is getting closer to the x-axis, that is true, but we would say less steep. So this time we would say as the slope decreases, the line becomes less steep. Alright. Okay, on this third one, it says, what would happen to our graph over here if we make the slope negative? So they already graphed a positive slope. They want us to graph a negative. So what's the only difference going to be?
One's going to be going the opposite way.
Yeah, that's going to be going the opposite way. So instead of going up 1 over 1, I'm going down 1 over 1. Very good. So is one of these lines any more steep than the other? No. So our steepness did not change. Like you guys said, it's now slanting the opposite direction. So the line will change direction, but steepness will not change. Okay, so with those conclusions that we drew, they want us to kind of summarize that here at the bottom. So it says, first of all, the steepness of the line is affected by what? What part? The y-intercept or the slope? Good. Okay, and when our then when it became smaller, like a fraction, what happened? Very good. I always want there to be a word where you can just add in something on the end for it to be the same, you know? That's what, when I taught Algebra 1 in Slayton, a kid said that, and that's what the whole class used the whole year, steepless. Like, I don't think that's it, but we'll go with it. Okay, and then a negative slope, is that going to change the steepness at all? No. So negative slopes do not change the steepness. Okay, so far, talking about our slope, all that's going to do is make our line steeper, less steep, or change its direction. It doesn't move anything else about the graph, right? Okay, so flip it over on the back. So it says to compare the steepness of the following lines. Well, you guys just told me the steepness is determined by the slope, right? The bigger the slope, the steeper it is. So, in y1, my slope here is, and in y2, so which one's going to be steeper? The 6. So y2. Okay. In the second row, what is my slope? -2. But does the negative affect steepness? No, so we're only really worried about the 2. And then what's my slope on y2? 1. So which one's going to be steeper? The 2. So y1 will be steeper. Okay? On the third row, what's my slope for y1? 2. What's my slope for y2? -2. So, is one going to be steeper than the other? No. Good. So these ones are the same. All right, and then in that last one, we got a half and 4/3. If you're unsure of which one's bigger, you can always put them in your calculator and turn them into decimals, right? What is 1/2 as a decimal? And what's 4/3? Other way around. That would be 3/4. 1.33333, right? So which one's going to be a steeper slope? Good. All right. So if they ever give you fractions and you're not sure, just type them in your calculator to convert to decimals. All right. So here they ask us the original function y equals 3/4 x minus 5 is graphed on the same grid as the new function 4/3 x minus 5. Okay? I want to know which of the following statements would be true about these graphs. Okay, so here's my first graph. So it starts where? -5. And it has a slope of 3/4. So I'm going up 3 and over. Good. Okay. So here is the first line, or the original is what they called it. So there's the original line. All right, and then the other one also starts at -5, but its slope is flipped over, right? So on this one, I'm going to go up 4/3. Okay, so here is the new line. That's what they called it. All right, so we're going to decide which one of these statements is true about those two lines. Well, first of all, the new line, is it steeper or less steep than the original? Steeper. So new has to be steeper. And did the y-intercept change at all between the two? So that part should be the same. Okay, so we're asking which one is true. So A says the graph of the original function is steeper than the new. Is that true, that the old is steeper than the new? No. Okay. The graph of the original function is parallel to the new. Right, these two lines are not parallel, right? Parallel means they never touch. All right, the graphs intersect at the coordinate point -5, 0. Well, -5, 0 would be over here. Do they touch there? No. The graphs intersect at 0, -5. There we go. Guys, put your phones up. All right. Number 3. If the slope of the function -4.5x plus 3.2 is changed to 1.5, which of the following best describes the new function? So, if this is the original slope and this is the new, what should I know about my slopes? Is one steeper than the other? Which one's bigger? Right, because the negative doesn't affect steepness, right? Okay, so we want to say that the old is steeper. Alright, so the old is steeper and the old slants the other direction, right? It's a negative slope. Okay, so A says that the graph of the new function intersects the y-axis at the same point as the original. Is that true? Did that part change? So did the y-intercept stay the same? Okay, so far this one's sounding pretty good, right? Let's check the others. The graph of the new function intersects the x-axis at the same place. No. The graph of the new function has a negative slope. Is that true? The original one did. And the graph of the new function has a positive x-intercept. All right. Okay, last one. Says which best describes the effect on the graph f of x equals -3x plus 7 if the y-intercept is changed to -5. So this time, we're changing that number, right? So my new equation keeps the slope the same, we just change out the y-intercept. So instead of starting at +7 and going up 3 over 1 or down 3 over 1 in the negative direction, it's still going to have the exact same slope, but now it starts down here at -5. Okay, so I connect my points. So this is the old, this is the new. It says the slope decreased. Is that true? No, slope didn't change. The new line passes through the origin. No. The x-intercept increased. Nope, right, it decreased. It was over here, and now it's over here. The y-intercept decreased. Yes. Okay.